get 28 at least.
Even the answers were even the like this what I would say about 23 or at least 23. Force of attraction should be C, this should be B, which I wrote B. And then this should be evaporation, name a substance that can sometime that was naphthalene was, and look to conditions by which I wrote temperature and pressure. Then rigidity I didn't define it.
If you just say temperature, you should say low temperature. Right?
There was also question which I read wrong.
And then everything was wrong.
This question I read.
Yeah, this question also. Why is considered?
I actually read it like name 2 points why what is compound considered. I didn't get the water, so I wrote 2 points of
anything of any component that it is present if it's proportion.
It is so yeah.
Okay, now what I want you to do is, all of you are having your question paper, no, at home. So you see what are the distinct questions that you have made a mistake. Write down the correct thing again.
Others I think this one good, this one good.
Yeah, but then you should cross check. No, suppose you have got something like whatever marks. See, with reference to your question paper, I want you to see what your mistake.
Mercury.
Mercury is there.
Mercury.
Calcium
Mercury
oxide
and
and calcium oxide is there. Element and compound, both of them will be considered there.
Because the question which I read wrong, first I read right, but then
You clicked it.
no,
Beyond it. Okay.
so I read the question wrong, but in the first try I read the question right, but the time was low, so I read the question in a hurry. Because of that,
So one most important thing, two things, one is your time management. Okay. If you're thorough with your lesson, you will not waste time on reading and like thinking. So that you have to be quick.
this happened in maths.
Also. So yeah. So anyway, we have completed 2 chapters. Now I want you to be thorough with these 2. Are you listening? These 2 chapters you have to be thorough. Because both the chapters will be once again asked for your school
The first
examinations.
chapter, the second chapter is coming for the second semester. The second chapter is fairly easy than the first chapter.
Whatever it is, what I'm saying is, since we have already completed this chapter, you have to be thorough with it because it will anyway be coming for your school examination. And I don't want you to be losing time there, right? We've got an advantage that we have already completed, we are thorough with the lesson. So we must start taking further. Okay? So let us start. We are starting with a new chapter today. Yes.
Atoms.
Atoms and molecules. Let me cross check with your new textbook. If there is anything that is missing.
Then I have converted in minus. In Celsius scale it is asked, na? Minus 275 I have converted.
Correctly. Okay. So once we start with the lesson, no more talking. I want everybody to concentrate, right? Come to chapter number 3, atoms and molecules. Okay. So the first part of the lesson, if you look at the page, it's more or less an introduction. An introduction to what is meant by that and what is a molecule. Now, in the previous chapter, we have already learned about different type of substances which may be present around us. Correct? If we talk about the nature of the substances, what can we think? Nature of the substances, they can be in a gaseous form, it can be in a liquid form, or it can be in the solid form. But then if you look at the chemical composition, okay, we can also be classifying the substances into what? Pure substances and mixtures. Okay. So many different type of compounds and elements and mixtures, etc. present around us. So scientists right from the very beginning, they are trying to classify, they are trying to find out what the substance is actually made of. Initially, of course, people did not know. Way back in 1700, maybe even in 1800, people did not even have microscope. Okay, microscopes were introduced or actually invented much later on. So how small the particle is, nobody knows about it. Okay, it was much later on that when people realized that substances can be made up of much smaller particles, that we started realizing that there could be something much smaller which is present in any type of a substance. Okay? And the earliest type of an explanation was given by this scientist. He's an English physicist. Okay, so he was Dalton. You must have come across Dalton's, yeah? Okay, because he was the one who understood that a substance can actually be made up of smaller and smaller particles. Correct? So he gave certain postulates. What is meant by a postulate is, he said, okay, there are set of certain observations that he saw.
Some rules which can be
some
like
obvious universal
obvious rules but
Obvious.
can be proved.
Yeah, these are the postulates. So he started putting it in the form of a statement. What did he say is basically he says that any of the substances should be made up of the smallest unit. Okay, and the smallest unit he began to call it as an atom. Now this word atom comes from the word atomos, basic unit. Okay, this is what is known as an atomos. Now we know with so much of research and so much of scientific advancement that an atom itself has got different type of properties. It has got some properties. Okay, what are these? They're made up of protons, electrons, and neutrons. But way back in this era, we're talking about some 1800, early 1900. We did not know anything about an atom. Just the smallest part was called as an atom. Okay. Then what did he say? That it was neutral. Obviously, it was not charged. It was not positively charged. It was not negatively charged. At that time, remember, we are talking about the beginning of the development of an atom. Only much later on, when people started conducting experiments and all, they realized that this atom itself is made up of three different types of particles. These are called as the electrons, then they are the protons, and they are the neutrons. Okay, we will talk much more in detail of the structure of an atom, but not right now. Then the statement of chapter itself is atoms and molecules. So what is a molecule? What is an atom?
is made up of two or more atoms.
Yes, it's made up of two or more atoms. Okay, for example, you can say molecule of an element. Okay, it can be a molecule of a compound or whatever it is. Wait, Nishat, I will tell you something to write, then you write. Okay, this is just an explanation that I'm giving you, right? Okay, have you followed? So it was Dalton, and he's credited because he has given us the idea of what an atom is. Okay, so that is the first part of it. Then we are going to be talking about certain kind of chemical reactions. Okay, oxygen was one of the elements which was widely worked upon. So there was a French scientist who was called as Lavoisier. So Lavoisier was the one who was actually working with oxygen, and he said that oxygen, many of these elements will react with oxygen to form different type of compounds. Okay, so a little bit of introduction to what is the structure of an atom, what is an atom, and how scientists actually perform different type of experiments. If you look at your textbook, or even if you are having your unit, okay, volume, you will talk in terms of laws of chemical combination. Okay, so what are these laws? Basically, it is a law, okay, of chemical combination. Correct? So here we are talking about a chemical composition. That means something is combining with something. Did you understand? So people did realize that sulfur is there. Sulfur can combine with oxygen. Nitrogen is there. Nitrogen can combine with oxygen. Okay, water is there. The water, what is water made up of? It is made up of hydrogen and oxygen. So that means there's some kind of a chemical combination which is taking place. Okay, and this is what they started talking about, and they started investigating regarding what is the nature and how are they actually, combination is taking place. So we are talking about the law of conservation of mass. So there are two laws. One of them is what is known as law of conservation of mass, And the other one is we are talking about constant proportion. So I'll be talking a little more. I'll switch on that. It's okay. That's fine. I'll switch on. A little circulation. That's all.
And that doesn't
Put up circulation. Is that okay? So I'll talk a little more regarding what are these laws of chemical combination.
This one.
I will first one. You want me to switch on?
Yeah, more than
Okay, so look at the first part. Okay, and also another very important thing is how are we going to talk about these atoms? Because atoms of an element, what are the symbols? What are the different types of symbols that has to be given? What are the rules, etc. that we are going to talk. Okay, so come on, right now. I'm giving you a couple of coils from. Did you write on the top? Chapter number 3, atoms and molecules. Have you written?
what should we
I
write?
can give you the first one. Yeah, just write history of
Atoms.
the development, history of the development of matter. In bracket you write on atom. Okay, so the first thing that you should remember was that sometime in 500 BC, he was an Indian philosopher. He was called as Maharishi Karan. Okay, I will not mention all of them. Small little bits of information which is given to
the
us.
name of the scientist.
John.
You have to write.
No, don't write.
John Dalton.
I will tell you about your. Okay, so the first one that you will write is Democritus, called, come on, write down. Democritus, Democritus, Democritus. Okay, called these indivisible particles, indivisible particles, atoms. Democritus called these indivisible particles atoms.
And you are the Indian.
No, Democritus was a Greek philosopher. Okay. And the meaning of atom is indivisible. Put it in bracket. Okay. It is indivisible. Next, the name of a scientist which I want you to recognize is Lavoisier. Lavoisier. Right. Lavoisier. Lavoisier.
Level 0.
And he established two important laws. Established two important laws of chemical combination. Now we are talking about the laws of chemical combination, right? Now what are the two laws? The first one that we are going to be talking is the law of conservation of mass. Okay. Here, the first one. Law of conservation of mass. What does it mean?
Conserving of mass.
Mass is expressed in what unit? Suppose I say 5. By what?
5 grams, 5 kg.
Correct. So unit will be grams or kg. Okay. So when we talk about conservation of mass, Basically, I'm just putting up something for you to
Ratio.
understand. Suppose you have got substance A,
1:2.
which is reacting with substance B, okay? And let us say it is forming two new substances, let us say C and D, okay? Now the mass of A and B is equal to the mass of C and D. Did you understand this? Okay? Conservation, that means mass cannot get destroyed. Suppose you start off with 80 grams of A and B, okay? You will get 80 grams of the product.
Yes, ma'am. I have heard that mass can neither be created nor destroyed.
Yes.
But I still don't understand because even we have mass.
Yes.
This is also mass. I can indirectly destroy it.
Destroy in the sense to what? It has to be converted into something else.
Break.
Okay. Ultimately, it will get converted into something else. And if you take the total mass of something that has been formed, okay, obviously, suppose I take carbon. Since you asked me that, yes. Suppose you have taken carbon, okay, you burn it in some amount of air. Air is what? Oxygen. So carbon plus oxygen will form what? Carbon dioxide. If you take the total amount of mass of carbon dioxide which is formed, will be the same as these two together. Did you understand? It can get converted into something else, but the total mass of the substance will be the same. Okay? Now look at the diagram which is given in your textbook. Can you see the diagram? There's a small vertical color here. Okay? Now that is an experiment actually. See, there is a conical particle, then there's a small solution X and Y. Correct? So you are, instead of taking A and B, you have taken X plus Y.
Right.
So when you're tilting it, what happens? X and Y is combining together and two other substances form, something plus something. Okay, so before the experiment, we are finding out what is the total mass. After the experiment has been done, we are finding out what is the total mass. Okay, will it change? No. Okay, so that is how, with the help of experiments also, we can find out that there is going to be a mass conservation. Mass will never get converted. It will never get destroyed. Okay, the only thing is one form can get converted into some other form. Is that okay? No. Take it.
The definition 1 kg of liquid is equal to 1 liter of petrol. As well as the
Kg and liquid, liter is not the same. We are talking only about mass. When you talk about liquid, then it will be in volume. Then you are talking about some ml. That is for density. That is water. Only for water you will have this.
like liter.
Yes, that is only for water. Why? Because I have already told you density is equal to mass upon volume. And for water, 1 gram of water is equal to 1 ml of water. Why? Because the density of water itself is 1 gram per cc. Only for water, not for anything else. Get it? Okay.
What does per cc stand for?
Cubic centimeters. Okay, or centimeter cube, centimeter to the power.
Next subheading.
Now, under this law of chemical combustion, the first law I'm dictating, law of conservation of mass. Take down. Law of conservation of mass states that, see here, it is there. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Created. You can't create mass.
Yeah, it could do.
Ma'am, you cannot create mass, but you can transform mass.
It can be transformed. Total mass
Not
not
to create mass.
okay. States that mass can neither be created nor destroyed in a chemical reaction. In a chemical reaction, okay, we are talking about a chemical reaction taking place. That's when mass cannot be. Right. Next one. Next law. Can you see the next law in your textbook? What is it called?
Law of constant.
Law of constant.
Yes, please write. Law of constant proportion. Okay. This is also called as, this is another name for it. This is also called as law of definite proportions.
In the chemical substance, the elements are always present in definite.
Wait. Law of constant proportion is also called as the law of definite proportion.
Constant.
Also called as.
Definite proportion. So if at all you see constant proportion or definite proportion, don't get confused. It means the same. Okay. Just below it right now. This law was stated by, I'm giving you the name of the scientist now. This law was stated by,
This law.
was stated by the name. The name of the scientist is Proust. Okay. Now I'm giving you the statement, so you write it in your important dollars. In a chemical substance, the elements are always present.
Chemical.
The chemicals are always,
The elements are always present.
elements are always present
In the chemical substance, the elements are always present.
in definite proportion by mass. In definite proportion by mass. Okay. Let's talk about a very simple example of the next law, which happens to be,
No, I got seven. Okay,
we talk about it. This is the first law. The second one is constant proportion. Let's take this example of water. Okay, this is with respect to mass, right? We want to find out how it is present. Now, mass of hydrogen is 1. Correct? Right? It is not in grams. It is what is known in AMU. I'll tell you a little more about AMU. That is atomic mass unit. So suppose I say 1, it is AMU. And now there are 2 atoms of hydrogen. Correct? So what will it be? Mass of hydrogen is going to be 2. Oxygen is 16. So it's always present in this ratio. So when you see the common ratio, let's say 1:8. Did you understand? Yes. Okay. So it is always present in constant proportion with respect to mass. So this,
How do you
Two
find
is to
out?
16, how do we find out?
how did you know that? Okay. Now this is hydrogen. I told you atomic mass unit of hydrogen is 1 and that of oxygen is 16. Okay. Now in the next chapter we are going to talk a little more in detail regarding what is the mass of hydrogen atom, what is the mass of, with respect to either the number of protons and the neutrons which are present. Right now you just take down this number and I will tell you a little later regarding the structure of an atom, how we can find out the mass. It's not here in this chapter. In the next chapter we will see. Don't waste your time now. Yes.
They'll come.
Finish writing? Did you write down this? I'll write it down. So now you will understand that it is always present in the ratio of 1:8.
It's 2.
Finish? Okay, now I want you to look at this law of constant proportion. Anna, you have your textbook with you now? Whatever it is. I'll ask him to read law of constant proportions from your textbook. Read.
Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compound had the same element in the same proportion, irrespective of where the compound came from or who prepared it.
You're paying attention?
In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8.
Yeah, come on, underline that point.
Whatever
shown you
the
the
source
how
of
it will be.
water,
No,
thus,
it works.
if 9 gram of water is decomposed 1 gram of hydrogen and 8 grams of oxygen are always obtained.
Did you understand now?
Yes.
Suppose you take water and you decompose it, obviously you get hydrogen and oxygen. So you get 1 gram of hydrogen and you get 8 grams of oxygen. Okay, it's always present in this ratio.
Similarly, in an ammonia, nitrogen and hydrogen are always present in the ratio 14:3. Ratio 3. By mass, whatever the method or the source from which it is obtained.
Did you understand this? Whatever the source or from where we are getting it. That means we are taking water from whatever source. Maybe it is tap water or lake water or river water. This one, don't talk with, I'm talking with. Okay, so from various sources, suppose you take water, you will always get it in this particular proportion. Did you get it? Yeah, next.
This leads to the law of constant proportion, which is also known as the law of definite proportion.
Underline this, definite proportion.
Definite proportion.
Constant proportion is also called as definite proportion.
This law was stated by Proust as in a chemical substance, the elements are always present in definite proportion by mass.
Okay, have you so far understood this? Now you see there's a nice photograph. You have, who is that person?
John Dalton.
Dalton, yes. So it was Dalton who actually took forward this idea of conservation of mass, constant proportion,
It
etc.
was one.
And he was the person who actually started defining and understanding what is an atom. Okay, he said it is the smallest particle of any substance, whether it is an the element or it is a compound. Obviously, it is something that is small and it is indivisible. At that time, they did not know that atom can also be made up of electron, proton, neutron. They thought that the smallest particle of any substance, this is an atom. Okay, it cannot be seen. It is so small, and we will now next see that how small is the measurement, because we are not talking in terms of meters or centimeters or millimeters, but we are talking about extremely small units. Okay, and that was possible only after the invention of the electron microscope, etc. So here are how small? 10 raised to the power of minus 9 meters, nanometers, not even micrometers, nanometers. You can't even see, you can't see, you can't even see. How about not even microscope? See now here. What are the postulates? What are the postulates of Dalton's theory?
All matter is made up of very tiny
Yes.
All matters
Read.
all matter is made
Yeah,
of
you read.
very tiny particles.
Read. Give him a chance.
So should I read
Yeah.
from the big box
No.
or starting?
You can read. Dalton, of course, was born
Should
in
I read from the big box?
1700.
John Dalton was born in a poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12.
Can you imagine at the age of 12? Oh, he must have been brilliant, no?
7 years later, he became a school principal.
At what age?
19.
Can you just imagine he becomes a school principal? Yeah.
In 1793, Dalton left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. In 1808, he represented his atomic theory,
He
which was
presented his.
He presented his atomic theory, which was turning point in the study of matter.
Okay, so now we are going to be talking about what is Dalton's theory of an atom. Okay, all of us will pay attention because I'll ask you now. All matter is composed of very tiny particles, and which we of course call it as atoms. Second one, atoms are indivisible particles. To a certain extent, it is right because it is so small it cannot be divided. Okay, it cannot be created or destroyed. Atoms of a given element are identical in mass as well as in chemical properties. What does it mean? Suppose you are taking atoms of chlorine. All the atoms of chlorine will be the same. Okay, suppose we are talking about sulfur. All atoms of sulfur element will be the same. Did you understand that point? Look at your textbook. Okay, atoms of different elements have different mass and have got obviously different chemical properties. There, atoms combine in the ratio of small whole numbers to form a compound. Did you understand that? What is the formula for sulfuric acid? Come on, you tell me. Sulfuric acid. Remember, I have told you.
SO2.
H2. I've told you many times. Come on, you should remember it.
H2SO2.
SO4, not H2.
You have to remember. This is it. So, what is the point here? That these are atoms belonging to different elements, and all of them are present, which are combined together in a very simple whole number ratio. Okay, did you see that? There are no fractions here, there are no decimals. That means they are just whole numbers. And they are very simple whole number ratios. We'll also later on understand how these atoms are combined with each other. And the last one is the relative number and kinds of atoms are constant in a given compound. Okay, so we put forward all these points. How many points do we have? 5 points. 5 or 6 points. Okay, put a tick mark. I want you to learn it up and write it for your homework. Correct? There are 6 points. Leave at least half a page of in your notebook, and you will write down. Come on, write down the question. What are the postulates? I'm giving you the question. Write down what are postulates of Dalton's atomic theory. What are the postulates of Dalton's
Atomic theory.
atomic theory?
Atomic theory.
Okay, so I want you to write down answer. How many points? 6 points. Leave according to your handwriting, you know how much you have to leave, maybe about half a page. I assume it should be half a page. Leave half a page and then I'm going to continue further. Okay, now we are going to talk about how are we going to represent these atoms. Right? Atoms are all of different type of elements. So when we are talking about elements, and we have seen that there are so many different type of elements, obviously the atom of all these elements are going to be different. Okay, so we have to show some kind of a symbol. How are the elements represented? They are represented by symbol. Okay, an element we are going to use a symbol, whereas a compound, how will you represent a compound? By using a
Periodic table.
water is an element or a compound? Okay. So how will I write? I'll write it as
Atomic
H2O.
mass.
What is H2O? Can you call it as a
Atomic mass.
symbol? Is it a symbol? It's a
No,
formula.
molecules of some
What is it? It
compounds.
is a formula. Okay. So how is a compound represented? It is represented by a formula. Will you remember this? How is an element represented? It is by a symbol.
Formula.
Okay, for example, hydrogen, oxygen, these are all symbols. But if they
LCM.
combine together, it forms a compound. Like for example, okay, write down this, leave half a page now. Half a page for your homework. Okay, write down. Okay, an element is represented by using a symbol.
Right.
By using a symbol. Example, hydrogen, oxygen. Okay, a compound is represented by a formula.
symbol by
By symbol, that's all.
Compound is
Examples are given here. For example,
represented
hydrogen
by-
and oxygen.
Ma'am, gold is also an element, right? So gold is A
AU.
and silver is Ag.
Yes. These are some of them are all Latin names. So the names like Fe for
Yeah.
iron. So that is ferrum.
AR.
and a compound.
A compound is represented by using a formula.
Uranium is U. Uranium is U.
Okay?
Mm.
Now, if you look at the next page, we are talking about how we are going to be talking about the various symbols. It's always going to be a capital letter. Like, for example, hydrogen. You know this, right? Hydrogen. We write it as capital H, not as small h. Correct? You know that. Okay. Sometimes what happens is they may have 2 or 3 of them starting with the same alphabet. Like for example, copper,
Calcium.
calcium, chlorine. How will you do this? Okay. So the first one will be capital, second alphabet will be small. Calcium, C capital, A will be small. Chlorine,
Cl.
C and L.
And
But why do we represent copper as
Cuprum. The actual name for copper is cuprum, so it is Cu. Okay, come on, take down this. Representation.
cobalt and
My next topic is representation of an element.
carbon.
Okay. Representation of an element. Always capital letter.
Examples.
Examples. You can write down a few of the names. These are some of the commonly used, so I gave you chlorine, copper. And there's a list which is given in table 3.1.
Yes.
Right. Please write it in your
This
notebook.
one.
3.1.
And the
3.1 is
second,
This one.
the second alphabet is always
not necessary.
Yeah, you
Okay, for
right.
example, Cu is
And
not there
lead is
here.
PB.
Okay, copper is cuprum, so the usually. Now here it is first and the second one. Here we are not writing here.
I'm saying the second alphabet is always like written like small ones.
It's so small, yes. We don't write it as C capital A capital. The second one is always going to be small. Okay. Is that okay?
Actually, right on.
Not now, I'll make you write afterwards. But I want you to learn it up first, and to our next class I'll give you a test. Just on this. Okay? So write there in your notebook. Learn table, what is it, 3.1? Is it 3.1?
Ah, very one.
Okay. Learn 3.1 well. Yes. Continue.
On next. On Thursday.
Wednesday.
By Wednesday should be. Most of it you already know, nothing much. Most of it you know.
Bromine is beer. Long.
Is that okay? Is that okay? Understood? Okay then. Now we are going to be talking about what is going to be the measurement of an atom. See here on this page. See this small. Like I told you, atom is so small, you can't even see it. Okay, so now how are we going to take the measurement? How can you find out what is the size of an atom, etc., etc. So obviously the units are going to be so small. Okay, a meter. 1 meter is divided into how many parts in terms of millimeters?
1000.
Correct? Okay, so 1000 millimeters will make a meter. Okay, now you have that 1 millimeter on your scale. Isn't it between 1 centimeter and 2 centimeter? You have got small divisions. So that is 1 millimeter. That also you can see. But you think keep on dividing into smaller and smaller and smaller parts, you get what is known as a nanometer. So 1 10 raised to the power of 9 nanometers is equal to 1 meter. So 10 raised to the power of 9 nanometer is equal to 1 meter. So this is something that I want you to remember. What does it indicate? How many zeros are there? 9 zeros. Have you followed? And you're taking one small bit of it. So million is 6. Okay, 10 raised to the power of 6 is a million. Okay, so a nanometer. So this basically, when we talk about units, obviously it is going to be A and U, which is atomic mass units, which are very basic. Now I want to just have a look at this paragraph. In this paragraph, what is an atom?
Yes, imagine.
Read.
Have you ever observed a moon building,
Mason.
a massive building?
Who is a mason? A mason? A mason is a person who is making all this, no, putting cement and brick and all that. Basically, okay.
From these walls, a room and then a collection of rooms to form a building. What is the building block of the huge building? What about the building block of an anthill? It is a small grain of sand. Similarly, the building blocks of all matter are atoms.
Okay, so what is the building block of all matter? What is this matter? What is it made up of?
Atoms.
It is made up of atoms. Okay, atoms may be of different elements.
How big are atoms? Atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper.
Just imagine this sheet. What is the thickness? It's hardly anything. Okay, so how many do we have? We have maybe millions of these atoms which are stacked together, and that will give you a thickness maybe of this. Okay, just to give you a little bit of information regarding how small these atoms are, we're giving you just different type of examples. Okay, now I want everybody to please write down right now in your notebook. Okay, the size of an atom. Sorry. What is an atom? What is the size or measurement of an atom, etc. Okay. Now, first point I want you to write down is the building block of all matter. The building block. What is an atom? The building block of all matter are atoms. Okay, atoms are very, very tiny. Atoms are very, very tiny. Next point you will write atomic radius. Atomic radius is measured in nanometer. Is measured in atomic radius. You know what is an atomic radius?
Is measured
In suppose this is an atom. Okay.
Far, like the far it can spread distance,
This is the radius, that's all.
right? From how far is it from nucleus, right? Or no?
Outermost. The outermost orbit of the nucleus, yes. Okay, so we are measuring it in
example.
atomic radius. You understand what is atomic? Just as you're having a circle and you want to measure the radius, this is an atomic radius because we are measuring in terms of atom. The atomic radius is measured in nanometer. How much is it? 10 raised to the power of 9 nanometer is equal to 1 meter. How much is 1 nanometer? Abhishek, come on, tell me.
1 meter.
1 nanometer is 1 meter.
No, 1 nanometer is
1 nanometer is how
1
much?
millimeter.
Sorry?
1 meter.
See, 1 meter.
19,
Tell me now.
19
Why 19?
And 1000 meter.
into plus 10.
1 upon 10 raised to the power of 9.
So then you add, you just
1 divided by 10 upon 9. So it is 10 raised to the power of minus 9.
And Luis.
You can understand?
raised to minus 9 and a
10
meter.
raised to the power of minus 9. See here. 1 divided by 10 divided by 9. So what is it? 10 raised to the power of minus 9 meter is equal to 1 meter.
Molecular.
Okay? So 10 raised to the power of minus 9 meter. You can understand that is it. 1 divided by 10 raised to the power of. Okay? Yeah. And then of course they've given you relative sizes of atom open or hydrogen, water, etc. Just to understand what are the various, okay, the atomic sizes of different substances. Clear? Yes. Now I'm going to talk about atomic mass. See this page. Do you see atomic mass? Are you
Oh,
ready?
yes.
Yes?
So what about what are the coordinates?
Whatever.
What are the coordinates of atom?
You don't have to learn this because this is outdated. This is they're just giving you symbols just to give you an idea of how in those days how people used to represent hydrogen, lead, copper, etc. But now this is outdated, isn't it? So we are using many symbols. So we are giving a lot of importance on how to write down the symbols. Now for atomic mass, it's a concept, it's a very difficult type of, it's not difficult, it's a different type of a concept and I want you to understand it very carefully.
Atomic mass.
Okay. Now suppose I say, first I'll tell you something that you can understand and then we'll take it up with atoms. Pay attention, pay attention. Okay. I say this is a short line, correct? Do you agree or no?
Yes, ma'am.
It is short. Is it short?
Yes.
Suppose I say A, you said A is short.
No. The B is
Now
short.
B,
B.
now what is A?
No.
No.
Longer than B.
So we are comparing it. Suppose I say now C.
Longest.
C is the longest.
Okay, so we are comparing the three different, the lines that I have drawn. Right? This is in terms of length. Now suppose I take mass. Okay, I say this is very heavy. Is it correct? No. Is it very heavy?
Yes. Like
Oh.
if you're
No.
comparing it from
Exactly. We always have to compare it with something. Suppose I take your school bag. Is it heavy?
no.
Yeah.
No.
Yes.
Bag will be heavy. This will be light. So it depends upon what you are comparing. Suppose I am comparing this with one sheet of paper. Will this be heavy? Yes. Did you understand what I'm saying? Suppose I am comparing three things: paper and the duster and your school bag. I'll say this is heavier than paper, but it is lighter than the school bag. Correct? Okay. That is exactly what we are doing for atomic mass. Absolute atomic mass is not possible for us to find out. You can't take one atom and keep it there and find out what is the
Absolute atom.
absolute is by itself. By itself. Like, can I take out one atom from there and measure it? It's not possible. Because it's very, very small. So what are we doing? We are comparing the atomic masses of various types of substances. So first thing that you should remember is hydrogen because it is the lightest element. Okay, we always used to compare it with hydrogen. And I say carbon is 12 times as heavy as compared to the mass of hydrogen. Okay, or oxygen, if I say oxygen is 16 times as when compared to that of hydrogen. What does it mean? If I put oxygen on one side I have to put 16 atoms of hydrogen to balance it. You understand what I am saying? If I want to measure carbon on one side, how many hydrogens will I put?
12.
I will put 12 such hydrogen atoms because hydrogen is taken as 1. Do you understand this concept? Yes or no? Why? Because we are comparing it. Okay. But now, of course, we said even this concept was very, very difficult. So we said that since carbon itself is much more stable, okay, how many hydrogen atoms are we putting?
12.
In order to balance one carbon atom, if you put on the side, you have to put 12 hydrogen atoms on the other side. Okay? So instead of putting 12, we say that hydrogen is 1/12 of carbon. One hydrogen is equal to 1/12 of mass of carbon. Is that correct? Did you understand? Did you understand it? So always whenever we are comparing the mass of any element to 1/12 of a carbon element. Got it? Yes? Now let's read this. See, there's an example here. They have shown you some watermelon and all that. Did you see that? This page. This page.
Next page.
What are we doing?
Watermelon.
Yes, watermelon, they have cut it into so many slices. Okay, and you're comparing it with, you're with some other fruit, some other
12
fruit.
pieces.
Okay, so you're comparing 2 pieces of some other fruit, apple or whatever it is, with 8 pieces of watermelon. So the same concept we are extending it to atomic mass. Did you understand?
Yes.
How much is hydrogen atom taken as? 1.
1.
If you are having 12 such hydrogen
Carbon.
atom, it is equal to carbon. If you are taking 16 such hydrogen atoms,
Oxygen.
it is equal to oxygen. Did you see that? Now there is a table there. Table 3.2, did you see? Hydrogen is 1, okay? Carbon is 12.
Nitrogen is 14.
Nitrogen is 14. What does it mean?
Nitrogen has 14 particles.
Not 14 particles. Not
14
14
atoms.
atoms.
No, I didn't say 14 mass. They're talking mass.
14 atomic mass.
It is atomic mass of nitrogen is 14. What does it mean? I have to take 14 atoms of what?
Hydrogen.
Hydrogen atom in order to balance one atom of nitrogen.
If you have to balance carbon and nitrogen, then
We have to balance these two. Okay, that is with respect to hydrogen, you will have to balance it. Okay, it's always, no, it is, we are having one standard. What is the standard? You have said that hydrogen is the standard. So you cannot balance, you cannot compare carbon with nitrogen or nitrogen with carbon. You have to compare nitrogen with hydrogen. You have to compare carbon with hydrogen. Okay, or if at all hydrogen is not there, then what did we say? We are going to compare it with 1/12 of carbon. Did you
you
get it?
cannot compare with like
No,
oxygen
you
and
can't.
magnesium.
If we compare anything with anything, it is only one standard we have to have. What is the standard?
Hydrogen.
Hydrogen. Right. Come on, right. Atomic mass. Atomic mass. Okay. The relative atomic mass. Relative is what? Not your uncle and auntie.
Comparison.
We are relating it
The
to
relative atomic.
the relative atomic mass of an atom, of an element. Yes, see here, the last line here. Write down this. Write down this.
Of an element.
Similarly, the relative atomic mass of an atom of an element is defined as the average mass of an atom as compared to 1/12 the mass of carbon atom.
And find out the average of the
Average mass of the atom. They are comparing the mass, right? As compared to 1/12 of the mass of carbon atom. Okay, we'll continue. Once again, we will continue with the statement. Right? Yes. Learn for your test. Okay. Thank you. Then, Kaushik, please see you to your class in your school.
APJ.
They're just telling what we have covered. Right? Thank you, children.
Carbon to electron.
मैं यार हूँ
इसको बोले इसमें